4.7 is now getting into mixed numbers. So we haven't done really any math with mixed numbers and keeping them mixed numbers. You can change them into improper fractions and do everything we've done up until now, or you can actually do math with mixed numbers, okay? So the first thing is just make sure we can graph them. We understand what a mixed number is. So a mixed number, remember, has a whole part and a fractional part, so it makes it a little bit more or a little bit less depending on which direction we're going. So where's -5 going to go? Well, that's pretty obvious. It's going to go right at -5, right? But where will -4.5 go? In the middle of -4 and -5, right? So -4 is here, but we're a little bit more. We're at a half, right? So -4.5 is right there between -4 and -5. What about 2 3/4?
You go down to the positive.
Yep.
And you get like right
Right
between.
against the 3.
Yeah.
Kind of. Our number line isn't the most spacious. So 3/4, think about it. 3/4 of a dollar, you have almost all of it, right? So 75 cents, 75%. So we're going to be like right here-ish. So that's 2 3/4. 1/8 is basically 0. You just have, I don't know if anybody cooks like 1/8 of a teaspoon. It's barely anything right here. So if we had cut the 0 to 1 in 8 slices, I mean, the dot itself basically is 1/8, right?
1/8 of a teaspoon is barely a drop.
You almost don't even measure it.
Right.
And then what about -1/2? Oh, I did it on the negative side. Anybody question that? Sorry. I want it right here on the other side of 0. Good. Don't listen to your teacher, do. And then where's -1/2 going to go?
Is it 1/2 or half?
It's -1/2.
It goes right in front of the 1.
Mm-hmm.
Yeah.
Not quite a negative whole, but definitely in the whole, right? So it's halfway between the -1 and 0 there. So they just want to make sure you have an idea of whole numbers and mixed numbers and where it puts you. All right? So how do we do multiplication or division with mixed numbers? You must change to an improper fraction, okay? So we can't just do the 2/3 times 11/15 and add the 1 there, okay? We have to change. So you must change them into improper fractions. It is a must, okay? So what is this first fraction going to really change to? 5/3. How'd you do that, Michaela? You got it. 3 times 1 is 3, plus 2 is 5/3, times 11/15. How do I do my multiplication? I multiply straight across the top and break down as I do it. 5 and 11 are both primes, so they're going to stay 5 and 11. 3 is a prime, but how can I split up 15? 5 and 3, or 3 and 5. Right? So again, I kind of do it a little weird, but that way you don't have to find the biggest common factor. So 5 times 11 are both primes. They stayed 5 and 11. 3 is a prime, so it stayed 3, and I broke down 15 to 5 and 3. At that point, you can see that they have a common factor of 5. So what remains on top is 11, and what remains on the bottom, you multiply 11/9. You got it. And you should be able to leave it like that. Just pay attention, because sometimes my math lab's picky, okay? So they might say, state your answer as an improper fraction, you're done. But they might say, state it as a mixed number, and you might have to go a step further. Email me if, like on a quiz, you do it one way but not the other, because you obviously did the math right, okay? On a homework, you can redo it, but on a quiz, I don't want you to have to redo the whole thing because they want it as 9 2/9 and you left it as 11/9, all right? Guys, this is not like anything new. We don't even have like a whole mixed number going on. So what's 18/1? So this is just 5 times, how can we split 18 up? 2 and 9, but how does 9 split up? 3 and 3. And again, if you want to do factor trees, feel free to do that. So the 5 stays a 5, and 18 changes to 2 and 9, which is 3 and 3. And then how does 6 split up? 2 and 3, and then we have a 1. And again, the reason why I do that is because you see that they have a common factor of 2 and a common factor of 3. We're able to reduce smaller numbers. So what does this just leave us with? 5 times 3, or 15 on top over 1, but that's just 15. Is that okay?
So why don't you any name with the 18?
The 18 split up to 2 times 3
yeah,
times
2
3.
times
Yep,
3 times
we
3.
broke him up.
Okay.
All right, number 4, what do we have to do with both of these? Change them both to improper fractions, all right? What will 3 1/5 change to? 16 fifths. How do we do that? Sorry, I'm like right in your way. 5 times 3 is 15 plus 1 is 16 over the same denominator. And then what's 2 3/4 change to? 11/4, because 4 times 2 is 8 plus 3 is 11. At that point, I'm going to multiply straight across the top, but when I do that, I break it down, all right? 16 is 4 times 4, but each of those 4s is 2 2s. So we have 4 2s for 16. 11's a prime, so he stays a prime. 5 is a prime, so he stays a prime, but what is 4 split up as? 2 and 2. Is that okay? And again, you don't have to do that. If you know 16 times 11, whatever that number is, over 20, and you can reduce that, feel free to do that. It just gets a little large, and so we tend to miss the greatest common factor. So I like to break them down when they're small. So what are we going to cancel out? 2 2s. So 2 times 2 is 4 times 11 gives us 44, and then 5 on the bottom is 5. And again, if they want to change it as a mixed number, you're just doing long division at that point. That would be 8 4/5 if you needed to do it. All right, it just gets bigger and bigger, okay, but nothing new. 3 will be over what? So this will be 3 over 1, and then this just gets kind of large. 15 times 6, I don't just know off the top of my head, so this is where I'm kind of going into the margin and doing a little bit of work. 15 times 6 over here. Let's see, 5 times 6 is 30. Put your 0, carry your 3. So you guys get 90. Does that look right? But don't get too excited because we still have to do what? Add the 7. And that's what I tend to do. I tend to think, okay, I got the big part, so it's 90 over 15. You know, don't forget that we always have to add that numerator. So we actually have 97 over 15. Okay? That's a big number, right? So when I go to multiply straight across, it's going to be 3. 97, you'd have to play around with it, but since it's odd, what do we know doesn't go into it? 2. 9 plus 7 adds up to 16, which is not divisible by 3 or 9, so we know that doesn't go into it. You might try 7. That doesn't go into it. It's actually a prime number, okay? Try 3, 5, and 7 for your odds, usually, okay? So 97 is prime, but then what can we split 15 up as? 3 and 5. Is that all right? So then that 3 will cancel out, so we're just left with 97 over 5. Does that look okay? It doesn't look good, but straight across the top, straight across the bottom, and at that point we're done. All right, so division is the same idea, okay? If we're going to divide, we have to make sure that all of our things are changed into improper fractions. We're not using mixed numbers at all. And when you divide, you're technically multiplying by the reciprocal. So this is 7 over 1, so how would I rewrite it as a multiplication problem? Yep, 4 over 9 times 1 over 7. Then I'm just going to multiply straight across. What is 4 split up as? 2 and 2 times 1. What is 9 split up as? 3 and 3 times 7. Again, you guys might have a number sense when you look at that you know there's not going to be anything that they share, right? 4 is a bunch of 2s, 9 is a bunch of 3s. They're not going to cancel out, so you don't want to split it up. That's fine. So in the end, guys, we're just going to multiply straight across the top to get us 4. And what is that going to be? 63? 3 times 3 is 9. 9 times 7 is 63. So 4 63rds. They didn't have any common factor, so I didn't really need to do that. But that's okay. I always do it just to save my butt, though. I feel like the second I don't do it, there's a factor there that I miss. All right, so the first thing we have to do is we're going to change this. We're going to keep it as a division problem first, because we have to change it to a mixed number. So 8/15 is going to stay 8/15. We're going to keep it as division still. And let's rewrite this as an improper fraction first. 3 times 5 is 15, plus 4 is 19 fifths. Does that look right? Okay. So I do that before I rush and flip it, because you have to know what you're flipping, right? So we have to change it to that improper fraction first. So this is the same thing as 8/15 times 5 over 19, right? Now I can flip it. And again, I kind of just go straight across. 8 is 3 2s, right? Because it's 2 times 4, and the 4 splits up as 2 2s. 5 stays a 5. What is 15 split up as? 3 and 5, and then 19's prime. And again, if you know that 8's not going to reduce with anything down there, don't worry about splitting it up. But you know that 5 and that 15 is going to reduce, go ahead and split that up, okay? So the 5's will knock out, which leaves you with 2 times 2 times 2, which is 8 on top. 19 over 3, I don't necessarily know, so I'm going to go over here in my scratch work and do 19 over 3. 3 times 9 is 27. Put down your 7, carry your 2. 3 times 1 is 3 plus 2 is 5. Do you guys get 57 there? Mm-hmm. And what's nice is that even as those are kind of big and numbers we're not comfortable with, we know they don't simplify any further because we saw right here they didn't simplify any further. So you know you're done. You can circle that. You can hit the enter on My Math Lab. All right, next one. Again, before we even change it to a multiplication problem, let's change them into improper fractions first. 7 times 3 is 21. 21 plus 2 is 23 over 7. Divided by, still keeping it division. 2 times 14 is 28. 28 plus 3 is at 31. Still over 14. Okay? So I haven't done any actually like computing yet, right? I've just changed them to those mixed numbers. Now that we have them as our improper fractions, we can leave the front number the same, 23 over 7, times what? 14 over 31. We can flip that guy. All right? I'm going to multiply straight across. 23 is a prime number. So 23 will stay 23, but 14 will split up as what? 2 and 7. 7 will stay a 7, and 31 is a prime number. So what are we able to eliminate? That factor of 7. And again, when I'm crossing out these 7s, technically a 1 remains, because a 7 over 7 is 1. 23 times 2, come over here real quick if you need to. 2 times 3 is 6. 2 times 2 is 4. So we have, what, 46 on top? Over 31. Again, it looks big and awkward, like you should be able to reduce it further, but you can't. You reduced it here, so it won't reduce any further here. Let's see what's going to be a good stopping part. Okay, we will go to...
Yeah, we got 2 pages.
Oh, yeah, there's a lot. We're not doing all of it today. So we will do... let's actually stop there.